Chapter 6 Internal Installation Pipelines. Unified Facility Criteria Design Petroleum Fuel Facilities UFC008 August 16, 2010. Department of Defense, United States of America. Approved for public release and distribution unlimited. Chapter 6 Interterminal Installation Pipelines. 6.1 Introduction. The chapter provides guidance for the design of pipelines. Military pipelines are typically either interterminal pipelines, which are cross-country, connect the government installation pipelines, which are connected to the petroleum, oil, lubricants facilities with even installation. Primary deficiencies are that interterminal pipelines cross public or private property, streets, highways, railroads, utilities, right-of-ways, and whereas installation pipelines do not. Interterminal pipelines may be dedicated to lines connecting two or more facilities, private-owned carrier lines serving several commercial military shippers. In some cases, shipping facilities may consist of relatively short spur by deliveries of the fuel suction side of the pumping station, which are part of the main line of the larger pipeline system. The pipeline receiving the dispensing facilities are normally part of the bulk fuel storage facilities, which are discussed in Chapter 3 of the UFC, and special requirements aviation turbine fuels of Chapter 4 of the UFC. 6.2 General Requirements. Chapter 2 General Design Information contains important information for the fueling facility design. Start the design of any fuel system without first becoming completely familiar with Chapter 2 of the UFC. Chapter 6.3 Design Requirements. Fuel segregation. Fuel cleaning products such as diesel fuel, distillate type of burner fuels made to be shipped in the same system without segregation. Batches usually pump product to product. They may be separated by fresh, suitable treated water. Separating pipeline systems are required with residual fuels for the Department of Defense projects provided with a dedicated pipeline for aviation turbine fuels. 632 Applicable regulations. Interterminal installation pipelines should be designed as described below, where federal, state, and local regulations are more restrictive with requirements indicated with the most restrictive requirements shall be applied. 6321 Installation Pipelines. Installation pipelines should be designed in accordance with the ANSI ASME B313. 6322 Interterminal Pipelines. The U.S. Department of Transportation regulates design, construction, operation, interterminal pipelines for liquid petroleum. Interstate interterminal pipelines should be designed in accordance with the ANSI ASME B314. Interstate interterminal pipelines should be designed in accordance with the requirements of Title 49 CFR Part 195. 633 Sampling provides a means of taking samples of the products shipped. 634 Pigging pipelines should be smart and pickable, including long radius elbows and bar fittings unless otherwise directed by the service headquarters. 635 Surge suppression provides surge suppression for the hydraulic shock when required. 6.4 Piping system. Refer to the Chapter 9 of the UFC for the information regarding pipeline system. 6.5 Equip all pipelines with meters of basket strainers provided with the capability to install proving meter. 651 meters. 6511 meters positive displacement. Use flange connected carbon steel body positive displacement meters. The desired pressure flow rating to meet the applicable service requirement. Ensure the meter has a case of its range register. Provide the temperature compensation adjustable calibration capabilities where there is custody and transfer. Ensure the meters accessories are compatible with either mechanical or electronic support equipment. Select and consult appropriate service headquarters for the requirements for the meter to communicate with the remote location equipment. 6512 meters and turbines. The flange connected to the steel body turbine meters of the desired pressure on the flow rate of the applicable service requirements provided the flow strain of the turbine meters provided with the strain length of the pipe. Minimum 10 pipe diameters upstream, the 5 pipe diameters downstream with all turbine meters that is required for the manufacturer. Ensure the meters have drain and register provided with the temperature compensation adjustable calibration capabilities where the custodial transfer. Ensure all of the supporting equipment for the meter for the capability of the turbine meter. Select and consult the appropriate service headquarters for the requirements for the meter to communicate with the remote location of equipment. Consider the use of the card operated with the key operated data acquisition system. Card and keys appropriate with the code for the identified with the receiver of the fuel to allow the access to the fuel. The quantities taken in and transmitted are data receiving devices, electronic pulse transmitter mounted on each of the meter. Each transaction is automatically recorded. 652 manual valve. 6521 materials construction. Require valves to have the carbon steel body of the bonnets. Do not allow valves with aluminum, cast iron, or bronze materials are used as the API fire safety valves. 652 isolation valve. Double block and bleed isolation valves. Use the separation product served the tank shell connection with the pipe going through and above below the ground between the pipe and tanker storage. Other locations are critical to pressure testing piping. Plug valves, double block and bleed. Use lockable double seated tape or lifted plug type valve that automatically bodily bleed between the seats, double block and bleed in critical application separation. The product surfaces on each of the line at the shore end of the piping goes above the below the ground between the pier and the tanker storage in other locations. Critical pressure testing of the piping. The valve should be designed so that the synthetic seating material is burned out of the fire. Metal to metal seat will remain effective closure. Comply with the APA standard 607. Lubricated plug valves are not allowed, including integral body cavity thermal relief valve. Ball valves, double block and bleed. The usual double-seated true union mounted blockable ball type valves with the body bleed beyond the seat. The double block and bleed. There will be very rarely, but acceptable alternative to double block and bleed plugs valves. The application where the valve is operated, but then frequently example the isolation in the middle of the piers that are only closed to perform the pressure testing of the piping. Piers valves should be designed so that their synthetic seating material to burn out in the fire metal to metal seat will remain the effective closure to comply with the API standard 607, including the integral body of the cavity thermal relief valve. The gate valves use the double-seated lockable gate type valve with the body bleed between the seats. The double block and bleed with the very rarely used the acceptable alternative double block and bleed plug valves and double block and bleed ball valves. When other double block and bleed valves will not physically fit, valves should be designed for the synthetic seating material is burned out into the fire. Metal to metal seating remain the effective closure. Comply with the APA standard 607. Single seated gate valves are not allowed, including integral body cavity thermal relief, quick opening, frequent openings, isolation valves. Use these for less critical applications where the double block and bleed shutoff is not required. 2. Ball valves. Ball type valves may be used. The valves are quick. If the frequent open application double block and bleed is not required, but the ball valve should be designed so that the synthetic seating of the material is burned out into the fire. Metal to metal seat will remain with the effective closure, complying with the API standard 607. Using Telfine, Vidon, synthetic seals and seating material. Use the full port ball valves for the exact diameter of the pipe with the 10 pipe diameters upstream, the 5 pipe diameters downstream. The flow pressure control valve with the flowing sensitive device such as a venturi valve should be complied with the APA standard 608. Butterfly valves are not allowed. Full port valves with exact same diameter of the pipe when line and picking is required. 6523 isolation valve operators. Provided manually operated valves are not specified with remote automatically emergency operation geared operated for the balls, double block and bleeds are larger than 6 inches, double block and bleed gate and ball, and double block and bleed valves specified with the remote automatic emergency valve. Emergency services, electrical motor operated, suitable torque limiting and controls, and auto-approved the service headquartered for the remote valves, considering the using the solar power batteries to reduce the cost of routing power for the motor. Operators provided locking tabs on the isolation valve to allow the padlocks to be used to lock out the valves during the maintenance. Provided with the chain operators on the valves, which are located with the 72 inches of higher above the ground. 6524 isolation valve location. Provide the local valves with the protecting pipe system for the control valve flow to permanent isolation equipment, the maintenance, the repair, provided additional valve with the required location necessary to conduct the valid hydrostatic test. Provide manual operated valves except for the motor operators specifically authorized applicable standards, drawings, and technical specifications. Double dot bleed dock and type of isolation valve for the separation product services. Use the tank shell connections AST over the 12,000 gallons or the piping goes service above and below the ground and rear of the tank of the storage or other locations. Critical period product pressure testing of the piping. Quick opening, frequent open type isolation valves may be used for the less critical application where a double block and bleed shutoff is not required. Before adding isolation valves, evaluating piping system made modification prevent pressure building up caused by thermal expansion. Review the paragraph on the relief valves in Chapter 9 of this UFC and a minimum requirement provided for the isolation valve at the following location. Provide a double block and bleed isolation valve at each branch line at the point of the connection of the main product pipeline or header. Provide a double block and bleed isolation valve on the product of the pipeline header just before the line leaves the valve pumping station. Provide a double block and bleed isolation valve in the inlet and outlet connection of each line of the strainer, filter separator, and meter diaphragm control valve, theme or relief, and other equipment that requires the periodic servicing on one inlet and outlet. Double block and bleed may be used to isolate more than one piece of adjacent equipment with other connected series. Provided with double block and bleed isolation on the open stream, on the upstream and the downstream side of each line blind with the connection to the cross-country pipelines. Provided with double block and bleed isolation on a main distribution pipeline immediately downstream of the branch connection with each of the existing future operating storage facilities served in the pipeline. Provide a double block and bleeding isolation valve with the intermediate points within approximately 10 miles and cross-country distribution pipelines facilitated isolation section line of the maintenance for the repair, provided with a double block and bleed isolation valve on each side of the water crossing exceeding of 100 feet in width near the shoreline of the submerged sea pipeline. Provide a double block and bleed isolation valve with the critical points for the pipe at the cross under runways, taxiways, or roadways for low point drains and high point vents. 6525 isolation valve pits. Provided with the fiberglass concrete pits with the rolling or hinge cover designed in accordance with the Department of Defense Standard Design AW78 2428 for isolation valves installed with the non-traffic areas, ungrounded fuel systems, design valve pits. Valve operators said the valve can be operated with the personnel without confined space entry. 653 other valves except the diaphragm control valve. 531 check valve. Using the check valve to prevent the backflow through the pumps, the branch lines, meters, and other locations run back of the reverse flow must be avoided. Check valves may be swinging the disc globe, double-plated hinge disc, spring-located poppet, valve ball, and diaphragm actuated type. Use the check of the soft-seated, non-slamming type of the renewable seat. The disc ensure the check valve to conform with the API spec 680. Use the diaphragm non-surge check valve with the flow control with the feature of the discharge of all the pumps in using the non-surge. Check the diaphragm control valve with the pump discharge, considering the use of the spring type of the water check before the diaphragm valve to prevent sudden flow with the reversal during the shutdown of the passing back through the pump and through before the diaphragm control valve. The diaphragm chamber is filled with the reaction closing valve. 6532 thermal relief valve. Provided with the thermal relief valves around the shutoff and check valve to relieve the excessive pressure caused the thermal expansion of the liquid trapped in between the shutoff points. See the facility plate 023, 024, 025, 026. 6.5 diaphragm control valves. Hydraulically operated single-seated global type diaphragm actuated control valves are used extensively in the fuel system as control valve. The valve consists of the main line in a pilot assist control system. The valve is operated with varying the amount of the pressure above the diaphragm, since the chamber above the diaphragm exposed to the greater diaphragm. The chamber pressure of the area is exposed to the line pressure. Equal pressure of the chamber of the pipeline results in the greater force being applied at the top of the disc. The force of the disc against the sheet those closing the valve is being liking the proper pilot control system. These valves can be used in numerous ways to control the pressure and level with the fueling system. Use extreme care with including the valves on the pipeline, as they are significantly contributed to the surge potential. If the close time is too short, whether properly adjusted, they can reduce surges. 5, 4, 1, 2, open and close operation. The most basic operation, hydraulically operated diaphragm control valve. The operation accomplished by applying the pressure of the diaphragm to close the valve, to relieve the pressure, allowing the blind pressure to open the valve. The pilot trim used to perform the operation. And three-way valve, which could be controlled in the solenoid hand pressure, the pressure differential, and flow. 6542 throttling operation. And the other method of controlling the hydraulically operated diaphragm control valve is the case of the valve modulates in any of the degree of the opening of the response changes to the throttle control. The throttling control reacts to the pressure, a pressure differential across the main valve with the pressure differential across the end, or if it's plate, it regulates the position of the disc in the mainline valve, provided with the full portion of manual isolation valves is placed within these limits. 6543 check valve function. Unique function of the control valve. In this case, the main valve outlet pressure is connected with the diaphragm covered. Therefore, the downstream outlet pressure exceeds the inlet pressure, which normally holds the valve open with the valve closed and the prevent backflow. 6544 remote operations. Hydraulically operated diaphragm control valves can be operated remotely. This is accomplished by installing the tubing from the point of the pressure sensing to the valve, or by reusing remote control solenoids with a trim. 6545 materials of construction using stainless steel pilots and stainless steel tubing used to the body and banana is covered made of the stainless steel internal plate of the chrome, the steel internal plate of nickel, modern iron provided with the V-Don, Buna, and diaphragm disc ring, enclosed all the electrical apparatus according to the classification of the area in which they are installed, provided with the means to wire seal to adjust the pilots. Do not use aluminum valves. 6546 application for the pipeline using hydraulic operated diaphragm control valves in the following application: rate of flow control, produce pressure reduction, pressure relief, and excess flow shutdown. 6547 the combination of these controls is also possible. 655 strainers required to strain to protect the potential pumps unless it precludes immediately the net positive suction head of the pump, whether or not strains are installed with the suction side of the potential pump. Install a spool piece and temporary strainer can be installed during startup. The strainers are not required. The suction side of all pumps and meter and the receipt of filterization. Strainers are not required upstream. The issue filter separated diaphragm controls also using flange strainers controlled with the seals and fitted with the removable baskets. The metal seals mesh with the large mesh reinforcements unless otherwise specified, provided with the fine screen mesh as follows: pump section central fecal mesh section over 108 thousandths of an inch. Pump section positive displacement mesh 40 to 16 thousandths of an inch. Receipt filtration mesh 40 to 16 thousandths of an inch. Meter inlets downstream of the filter separated 40 mesh and 16 thousandths of an inch sizing opening. In all cases, ensure the effective screen area is not less than 3 times the cross-sectional area of the pipe. The strain upstream of the pump should be quick opening the single screw type of the drain connection at the bottom. Provide the proper gauge with both sides of the strainer and differential type of the gauge across the strainer. 656 surge suppressors. Every effort should be made with the control of the hydraulic surge. Acceptable limits design piping system rather than using the surge suppressor where not possible. The extremely impractical surge suppressors may be incorporated the diaphragm bladder to equip with the top mounted liquid filled pressure gauge with the water style check valve at the bottom, drain bulb at the check of the valve, and isolation valve provided with the needle and around the check valve to permit the control black of the back of the surge suppressor without rebound. Locate the surge suppressor and close the possible to the point of the shutoff except to cause the shock. Surge suppressor can reduce the occupancy pressure but will not eliminate entirely. Provided preferred solution of the hydraulic shock is conservative pipe design using loops and slow closing valves. Surge suppressors are a strictly last resort solution. Require approval of service headquarters part of the design into the system. 657 pigging equipment. Equipping all the pipelines without outlets to allow the connection of pig launchers received with the design of the outlets that can be accommodated in internal non-destructive inspection training. Provide sufficient curvature bands of the pipeline to permit the free passage of such equipment provided with the T's and factories installed the internal guide bars at all branch connections. 658 pumps. Primary pumping facilities are discussed in Chapter 3 with the unified facility criteria, but the pumps are required to keep the pipeline pressure from the safe limits provided that them are appropriate location. Chapter 3 also provides the guidelines for the pumping facilities. 659 sample connections. Provided with the connection of the sample fuels on one section of each fuel transfer piping system, and install the sample testing selections of the receiving point tank outlets and inlet and outlet side filter separated fuel dispensing points between the isolation valves so that the remaining fuel in each portion of the fuel transfer pipe can be sampled where it is possible. Installing sample connections in vertical runs provided with the 1/4 inch diameter sample point with the probe ball valve with a quick disconnect with a dust cap. 6510 special consideration for aviation turbine fuels found for inbound filterization aviation turbine fuels. Refer to Chapter 4 of this UFC. 6.6 product recovery system. Provided with the product recovery system collects and store unusable aviation turbine fuel that would otherwise become waste of the operational maintenance activities. Consider a product recovery system over the other products. See Chapter 8 for the UFC for the product recovery system. Chapter 7, 6.7 canopies. 671 canopies protected with the fixed assets, unless otherwise directed with the service headquarters provided with the canopy to protected with the fixed assets of the equipment for the elements fixed assets. Fixed facilities equipment included but are not limited to pump pad, filterization pan, meter pads, isolation valve pads, tank structure, anchor car, offloading and loading equipment pads, control panels, electrical panel, motor control centers, ensure structural design in accordance with the UFC 008, UFC 30101. Canopies to reach stormwater. Do not provide with the canopy to preclude the rain from reaching the contaminated area unless it is required by the federal, state, and local regulations. Is economically justified by the reducing side of the concrete remote spill containment, the spill treating the system, or if directed by the service headquarters at a canopy of the tank trucking for the tanker car loading and offloading contamination area, ensuring the underside of the canopy is high enough to provide operator with a headroom when walking to the top of the truck or car. Ensure the structural design in accordance with the UFC 1-200-01 and UFC 3-3010. Special calculation pipeline venting of the time of the draining shipping time. The larger and the longer the pipe, the greater the volume of the fuel required to fill in the line. Therefore, the greater the volume of the air required to be vented. Under supersized vent lines will be delayed. The filled lines delay change over the product of the multiple product line size vent lines allow the filing of the line not to more than 4 times the design transit time of the line. Where applicable, connection vent lines to be system drain lines to avoid spills. To environmental, check the vent line air velocity must exceed with allowable air velocity to electrical static buildup. In accordance with the API RP 2003, vent rate must be not less than the lowest allowable pumping rate for the ship or the shore. Vent rate must be less than the design transit velocity to minimize hydraulic shock. Chapter 7 ground products fueling facilities.